Okay. Thank you everyone for attending. We really appreciate the time to talk to you today. What I'm going to talk about today is infrastructure and how you can use your infrastructure and optimize your infrastructure in Hadoop using the built-in functions that are already there. So first I'm going to go over the tiering and archive capabilities in Hadoop, and then how you can take advantage of these and really optimize your Hadoop infrastructure. So that's going to be the content of what we're going to go over today. So I'm just going to jump right into it here with the first slide. So what you see here is the built-in capability of tiering within Hadoop today. So it's also called heterogeneous storage. That's another name for it. And has anybody used heterogeneous storage capability or tiering function in Hadoop or archiving Hadoop? Anybody?
Our
Yeah, I know you have. Yeah.
Yes.
I mean, a lot of you have heterogeneous environments because they're mature environments, and you've had different types of servers come in and out of the cluster. So a lot of you have heterogeneous infrastructure, but how can you best use that infrastructure? How can you get the right data on the right infrastructure in these clusters that you have? So that's kind of what we're going to cover today with this talk. So today, built into Hadoop, you have two very key components of metadata that apply to this heterogeneous storage. The first piece of metadata is the storage policy, and the storage policy is applied to files, it's applied to directory structures in HDFS. And so when I tag something with the storage policy, I'm specifying that that data should be on that specific storage policy. Now what does that mean? That's where disk types come in. So disk types are another type of metadata, but this piece of metadata applies to the local file systems on your data nodes. So you can specify what type of storage that particular file system is. You can tag it. And you can tag it with things like SSD, disk, archive, RAM disk. You can specify what that local file system is and use it for the appropriate data within your environment. So these two work hand in hand. They're also very flexible. Remember, we're just tagging things with the specification. It doesn't mean that that disk has to be SSD. Maybe it's just faster processing nodes that we brought in that have faster processors and the same type of disk, but can process the data a lot faster. That could be specified as an SSD node within your environment. So you have a lot of flexibility in how you can use this functionality. But the key is to get the data in the right place. So now that you know the two components, let's look and see how it works. Right? So I got a very simple example here. By default, everything goes to hot. That's the storage policy. And what hot means in the storage policy table here is that you'll have the amount of replicas that are specified for hot to be on disk. Okay, so that's the default. So when I look at this example, my data starts out on hot and disk, and that's where the data lives. And you can see that I just made a sample file here. Query2CSV, that's in that directory structure. Just so you can visualize what's going on here. Okay, now, when I change the storage policy or tag the different storage policy on that particular file, and again, it could be a directory structure, that works just as well. And everything below that directory structure will inherit that policy at the higher level. So when I specify the cold policy, you can see that the data actually has not moved. It's tagged to be cold, but it hasn't actually moved to an archive layer, right? And if I have 3 copies of it, the 3 copies would move to archive once I've tagged the storage policy. But it doesn't happen yet. I just tagged the policy. So the data is still in the exact same spot it was, all 3 copies in that area of disk. And you can see obviously that the file in the file system hasn't changed either. The transparency of this mechanism in Hadoop is at the application level or user level completely transparent. You don't see any differences to where the data lives. Now if I go ahead and run the mover code within Hadoop, now that file will actually move to archive disk that's in my environment. And I just give kind of an example down at the bottom. You can see that these nodes have a smaller capacity of disk, more compute for hot nodes, and these have a much larger density of disk and less compute for the cold or archive nodes. That's just an example. Again, it's very flexible. You can use it in a lot of different ways. That's just a very simple example. But you can also see that even though the file and all its copies move to archive, the file itself still stays exactly logically in the same place in the file system. So again, from an application and user point of view, it's completely transparent. But the name node in HDFS knows where to put that data now that you've assigned it policy. All making sense? Okay. All right, so when I started working with the customer on this particular project, they really wanted to do this tiering function and this archive function in Hadoop. And my first question was, why? Why do you want to do this? You know, isn't Hadoop already commodity storage? Isn't it the cheapest storage on the planet? Why did they build this tiering function in the first place, right? Everything I've shown you is built into Hadoop, so why is it there? And as I worked with the customer over the last 2 years, really, we've really learned the value of it, and there is high value of it. So let me try to explain again with a very simple example. So traditionally, Hadoop, the storage component of Hadoop is typically a little lower capacity in terms of the amount of disk because you want a high amount of compute to process the data so your jobs don't slow down. You want to have fast job processing in most cases. You want your jobs to complete in a certain amount of time, and you want them to be consistent. That's even more important almost, is you want a lot of consistency in how your jobs run. The problem with taking this approach is that if you look at the overall price of the capacity of your Hadoop cluster, especially as you scale out, you're paying a lot per gigabyte. You're paying 5x to 10x is what we saw in this particular customer, and we have now several customer installs, and we're seeing the same type of results. That the storage is quite expensive per gigabyte because you're really kind of scaling on compute and trying not to put too much data on those compute nodes so you get that consistent result. So if you were just taking the built-in function of Hadoop and you were putting in a new SKU in your environment, and you said, hey, I want to max out the cost, I want to save the most amount of money on disk I can, I'm just going to make these really dense nodes and I'm going to put them in the cluster. Well, guess what? It's all transparent, remember, to the application and user. So you have to make sure, if you're doing this, that you have the right data on that denser platform, because you're going to have much more limited compute resources for that capacity. So you have to be very careful. So very good in terms of the cost here when you're doing those dense nodes, but it can really severely impact the performance of your jobs and the consistency of your jobs. You might pulling your hair out trying to understand, like, why is this job running faster than this job? It's the same exact job. You know, why did I get two different results? So you really have to understand what the underlying infrastructure is and make intelligent choices on what to put there. And that's the real magic to making this all work. The built-in function is nice and it can save you money, but you really have to understand what data to put there. So this is kind of the ideal, right? I want all the hot data to go to these high compute, high processing nodes with faster disk, and I want the denser disk and lower compute to take the data that I seldom access. I don't use that much. That's going to give you the best of both worlds, right? But when we're talking about millions and billions, we have customers that have billions of files and billions of transactions a day. This is a very complicated and time-consuming task to make sure that the proper data is on the right infrastructure. So, how do I utilize this function to make my infrastructure more optimal, have it perform better, have it cheaper? How do I do that and use this built-in function without affecting performance? And the answer is to tier your data intelligently. And so we've kind of come up with this concept of the pillars of intelligent tiering for Hadoop, okay? And so what you see here is I really need all these things in order to make sure that I have the right data on the right infrastructure in my Hadoop environment. So let's go down the line here. Heat. Heat is probably the most important at all of them. And what we mean by heat is the access frequency of that data. How often do I access that data? When's the last time I accessed that data? You know, when do I normally access data within the environment? So heat is a very, very important component. Knowing the usage patterns of your data is very important to doing this right. Now, you might ask, like, is that there in Hadoop? Do I have that information in Hadoop? It is there. It's in the metadata of Hadoop, but it's not obvious and not easy to get, right? It's just not. And I know your group has worked on this, I'm sure. It's a time-consuming effort for most companies, very difficult to do. But it's so critical in making sure this works, this capability works. Age is another component. Age is kind of the easy one, right? Everybody can understand what the age of their data is, how long files have been around, and I want to access, I want to archive all the data that's 7 years old in my cluster. Well, that might be a good idea, but we don't know. Maybe that data is data you access all the time. It's very possible. We've seen it. I'll show you some examples of it. We've seen that age cannot be the only criteria. Even though that's the easiest one, it's the lowest hanging fruit, you can't just use age to archive the data and put it on the right infrastructure. What we've seen, for example, is that, let's say in a 10 petabyte cluster, we've seen 2 petabytes be accessed for longer than 90-day periods, right? Now, a lot of the data you access for 1 day and never access again. So you have to understand what the data patterns are in order to make intelligent choices, and age is just not enough criteria to do that. By the way, I just mentioned that, and that's what we call usage, or some people call data velocity. That's another important component. Knowing what the data velocity is means that I'm going to understand that once I ingest a file into Hadoop, how long do I use it for typically? Do I use it for 1 day? Well, what we've seen is there's a lot of data that's ingested, used for 1 day, and never touched again. We see a lot of that. But we also see a fair bit of the infrastructure and data that's used for quite longer periods of time, and access for those longer periods of time. So you really have to understand the usage patterns as well. And then size. Why is size important? Well, you don't want to move a bunch of 0-byte files to archive, and we've seen a lot of 0-byte files. We've seen a lot of small files, right? So knowing the size is also very important for this function. You're not going to get any benefit really from moving small files to an archive layer. What you will benefit from is understanding what those small files are, and maybe moving it to a HAR file or some other archiving procedure that you can just get them out of there. 0-byte success files. How many of you guys have? I've seen 84 million in the cluster. I've seen a lot. So that's obviously a very important component as well. So if you have all this information, you can make very intelligent choices and really benefit from this capability in Hadoop. But you really need to have these things. So that is really the problem that we were tasked to solve. And that is what we built for this customer and now have as an available product for Hadoop administrators all over the world. And so let's take a quick look at that. This is our approach. The first thing we wanted to do is to be able to give you all this information and allow you to automate the optimization process without installing any software on the cluster. Because we know that, these clusters are mission critical in many cases. We have a lot of data on there, and this just makes it easier to build something that sits completely outside the data path, yet makes really what we call a shadow meta file system of the Hadoop cluster itself. So we understand all the transactional components as we gather the metadata that's available to us in the cluster, and then we crunch it, we process it, we analyze it, we give you reports, we help you understand what all those things we just talked about regarding your data are, the heat, the file sizes, the activity, all those things we're showing you and visualizing in reports. And then once we report this information to you, the next step is to allow you to customize rules to say, yes, one question, I'm sorry, go ahead.
I'm asking about before slides. As you see, we can categorize the data according to size, age, so forth. And it be also available to address the issues of business. For example, financial data may be very important and critical for an organization to achieve that data in milliseconds or seconds. Can it also be marked logically for some sort of data?
Yeah. So the question, I believe the question, and correct me if I'm wrong, but I'm going to kind of summarize it, is that can I pin particular data so that it doesn't move, or specify particular file structures or applications so that my data for these particular apps is always on a particular tier and is classified as such? Is that the question? Okay. So the answer to that question is, as long as you have a file level granularity view of your environment and a directory structure view of your environment and how it's used, then you can go ahead and classify the data any way you want. And as I was going down the line here to the optimizer, which is actually the automation tool that we include in our software that will go ahead and actually perform the changing of the storage policy and allowing the mover code to go ahead and move it within Hadoop. That capability allows you to exclude particular directory structures, particular applications, particular file sizes, only move a certain amount of data at a certain period of time. There's a lot of parameters that you can put in because we have a file level granularity view of the environment. So really you can do anything you want. It's completely customizable. And that's what this rule engine is that we put into the optimizer tool. You can say, as a simple example, I want to optimize all data that hasn't been accessed for 90 days, but I don't want it to touch HBase, right? So I can run a rule that will allow me to do that, and I'll list all the files and directories that are going to move according to that policy of data that hasn't been touched for 90 days and is not in the HBase application structure of my cluster. And I can move just that data. Make sense?
So one request I have is if you can please hold off your questions till the end. We'll give a few minutes. That way the flow of the presentation for the rest of the attendees continues.
Okay. How am I doing? Am I moving around too much for you?
No. You're okay. I'll actually bring some of the mics, keep it handy so that the person who questions, the question can be heard by others.
Yeah. So just a quick review. We're talking about there, after we customize a rule and I say, hey, I want all data to move that hasn't been touched for a certain period of time, to archive. Once I've specified these particular rules in my engine and I can specify file size, etc., then I can go ahead and optimize it. Basically, our optimizer will take the data that's the result of those queries. It will put it into usable batch files that are specified by you. It could be by file, the amount of files that you want to change, the amount of data that you want to change. You can exclude and ignore particular directory structures. All those things can happen with the optimization engine. And here's what it looks like. So again, we sit completely outside of the cluster itself. We communicate with the name node over the built-in APIs that are in Apache Hadoop. So whatever distribution you're running, completely irrelevant to us. We go ahead and we just use the APIs that are in Apache. Now you do have, For our software today, it has to be HDFS. So if you're running a version of MapR with a proprietary file system, or IBM's distribution with GPFS, we don't work with that today. We're just concentrated on elevating HDFS open source to this type of capability, right? Interestingly enough, a lot of the proprietary versions will sell this capability as a key feature as to why you want to put your data on their proprietary file system. So again, we sit completely out of the data path. There's no software that we install on the cluster itself, so this really minimizes any risk that you have of checking out the software. In fact, I'll make this, our software installs in 15 minutes and we can gather the data and process the data. Depending on the size, maybe at Yahoo it might take us a day or so to finish the initial baseline processing, but most customers can finish within an hour. We can have all the data crunched and analyzed and give you what we would call a health check. A point-in-time look at how your data is being used and how your data is being accessed in your Hadoop environment. We can do that very simply as a POC or demo in your environment. Very small footprint, virtual machine or physical server, whatever you want to do. Some people give us a node that they've retired out of the cluster. We don't need a lot of horsepower to get the data processed. And this is kind of a summary slide. So with our software, you can really answer all these questions. What data have I not accessed? Who's creating or making all these small files? What applications are making these small files? How do I deal with these small files? And you can better plan your infrastructure. So, or just deal with new equipment that you're getting that's coming into your infrastructure, right? Making sure that newer gear that can process the data faster is going to be used and used well. And you can use these tags that I talked about to make sure that data moves to the appropriate place. So with that, I thank you guys, and I'll take any questions that you have.
Is it open source?
The question is it open source? Right now, it's not open source. So there are thoughts we're having to open source the software, but right now, right now it's just a software package. We license by the cluster though. So for the Yahoo 6,500 node cluster, they're going to get a really good deal on it because we only price per cluster. Go ahead.
You mentioned not supporting proprietary file systems like GPFS, but what about S3, which is natively supported?
Yeah, so the question is, actually they could hear you.
I guess two questions. First is your support for it, but also Hadoop tiering policies as applied to S3, because there are no directories yet.
Right. So you're not going to have the transparent capability that I showed you here that you get with HDFS, right? Because S3 is a different file system than HDFS. But if you say had an instance of Hadoop running in EC2, and you wanted to keep that cluster kind of lean because you're getting charged quite a bit for that compute and processing, and you wanted to move the data out to S3 that's not getting accessed anymore in your Hadoop cluster, we can help with that. We can help identify the data in that cluster, and we can help move it out to S3. That being said, that's not a transparent tiering of the data, right? The data is actually moving out of the cluster into S3 because S3 is a separate file system. The name node is no longer going to be keeping track of the data that moves to S3. Now, if you're running Hadoop on top of S3, that's something that we don't do right now. Make sense?
Yep. Okay.
Any other questions? By the way, I just have a quick question actually. How many people are running their Hadoop environment in cloud? And how many are running in private infrastructure on site? Okay. Great. There was one more question in the back.
So did you say this is completely transparent to the existing infrastructure? So is it purely based upon placement policies, how you do this?
Again, I'll try to interpret the question, correct me if I'm wrong. So, the transparency is really at the application and user level, right? The file doesn't move in the directory or file structure of the file system. The virtual HDFS file system, the file doesn't move. So that's the transparency. The name node itself in the infrastructure knows that now that file is supposed to live on archive, and as soon as you initiate the mover code, I'm going to go move that file to archive. So the transparency is really at the user and application level, not at the infrastructure level. The infrastructure is aware that these file systems are tagged as storage type archive, for example. And the name node is aware of these files or directory structure are tagged as storage policy archive, for example. Does that make sense? Does it answer your question? No. Follow up?
So there is no change in the Hadoop distribution, right?
That's correct. All that is, everything I showed you in the first 6 slides are in Hadoop. The problem is it's difficult to use without the proper intelligence and analytics that go along with it. And there are customers who try or use Age, but that you really need all the information in order to make intelligent decisions on this type of infrastructure use. And again, as your cluster grows and ages, you're going to have a heterogeneous environment. So this is really important information for you to have. Any other questions? Yes.
So you collect the data.
One second.
I'm sorry. You collect the data outside of the Hadoop system. Understand that. After you collect the data, you're going to put it into the configuration inside the Hadoop class configuration. Right. So they can activate your policies. Those policies is dynamic or static. Once you put it into it, how long will it last? How often you're going to change the configurations? Thank you.
Got it. Yeah, no problem. This is a handy question for my backup slide. So this is really how it works from a mechanical point of view within Hadoop. Our software will go to HDFS and apply the metadata change for a storage policy for the particular files. Okay? And we'll do that based on the rules that you're creating. So when a rule changes that, say that file starts getting accessed again, your rule says, hey, if the file's getting accessed within this period of time, or has this many accesses, I want to move it back into hot. You can automate all that with our software. But the actual mechanism that's going on here is that our server is going out through an HDFS type client that we've streamlined a bit to go to HDFS and change the metadata information for the file directory structure or file. So that storage policy, once appended to that file, that is the storage policy that is now a part of that file. It's part of the file's metadata in Hadoop. Once the metadata is there, then files are optimized during the normal balancing window, just as if you change replication policy on a file. Same type of process. Once the balancing occurs or the mover window occurs, you'll go ahead and move that to the proper storage type according to that policy. The policies are fixed. They're built into Hadoop. I can't change them. You can't change them. They're fixed. So that first slide is what those storage policies are. That first slide. Oh. Aha. That one. So those are all built into Hadoop. Nothing for you to install. Nothing for you to change. You can't change them. They are And that's the mechanism that we leverage. But we apply the intelligence to give you the ability to use them. Most people, a lot of people are not using those today because they just don't know what data to put on those particular tiers. And it's too bad because they're putting this infrastructure in, but they're using it just as a normal node. So older nodes or slower nodes are not getting utilized in the right way as you scale out your cluster.
I think we'll call a closure for this session.
Thank you, everybody. Appreciate it.
Thank you very much, Pete, for the great presentation. So we'll just have the slides changed and we'll invite the next speaker.